This stone cost over $10,000 and it was completely destroyed by a tap against a kitchen counter. So what the hell is going on with gemstone pricing? It seems like a lot of the time the price and the quality have zero correlation. I totally understand the confusion. Half the time I'm confused as to why people pay what they do for certain stones. Gemstones might be the easiest place to accidentally lose your money outside of a casino. So today I'm breaking down 26 gemstones to help you avoid a very expensive mistake. By the end of this video you'll understand why some $10,000 gemstones break like glass, which stones jewelers actually trust for heirloom jewelry, and why I'm the world's biggest sapphire simp. And just before we start, I need to explain some things that you'll have to understand for this video. Hardness is not toughness. Hardness is scratch resistance. Toughness is resistance to breaking. Some gemstones are very hard but still fracture easily. And there's one more concept that shows up a lot in crystals called cleavage, which means the stone has natural structural planes where it prefers to split. This is a fundamental rule of gemstone selection. Think of it like wood grain. If you chop with the grain, it splits pretty easily. Let's start with some beautiful disasters that break if you look at them funny. Pearls are not what you want for durability. Mohs of like 2.5 to 4, pretty much any gold alloy is harder than these. Furthermore, calcium carbonate will literally dissolve in mild acids like vinegar or your sweat if you're a particularly acidic person. Cleopatra famously dissolved the pearl in vinegar and drank it. Mechanically speaking, that does check out. They're going into F tier. Opals make me so sad. They're so lovely to look at, but they want nothing more than to break your heart. They have a Mohs hardness of 6, so they'll scratch pretty easily. They're very brittle, and they love to chip. This is why opals are so commonly seen in bezel settings. Jewelers don't do all that just for the love of the game. It's primarily about protecting the stone. An opal's edge is so fragile that leaving any part of it exposed is just begging for it to chip. But a potentially bigger issue might be the chemistry. Opals contain water, sometimes up to 20%. If they dry out or if you expose them to rapid temperature changes like washing your hands in hot water and then walking outside into the cold, the stone can just physically crack from the inside out. It just explodes. It's a phenomenon called crazing. I want to love them, but honestly they are way too expensive to warrant their lack of durability, so they're going into F tier. Imagine if opal was green and really loved breaking in half. People check the Mohs scale and they see that emerald is an 8. They think, great, that's hard, that's durable, but they're wrong. Like we said earlier, hardness is just scratch resistance, it's not durability. And emeralds possess a property called brittleness that is a jeweler's nightmare. You know, like the emerald cut, like the rectangle with the corners chopped off? They didn't invent that shape just for fun. They invented it because it was necessary. Because if you leave a sharp corner on an emerald, it acts like a stress point. During setting, if you apply even a tiny bit too much pressure to that corner, you'll literally just break the whole thing off. Emeralds are also naturally full of inclusions called jardine, garden in French. Think of it like a windshield that comes already cracked. It's under constant internal tension. This isn't even going to the fact that at least 90% of them are oiled up or resin filled. So if you soap them too much or put them in an ultrasonic cleaner, it strips the treatment out and it might just completely break. Once again, I want to love them, but they need to be in E tier. Feldspar is a general category of minerals, including moonstone, sunstone, amazonite, and labradorite. They all have two strong cleavage planes that intersect roughly 90 degrees. Cleavage planes alone aren't enough to completely disqualify a stone, as you'll see later in the video. Many stones have cleavage planes. The real problem is a combination of three things: relatively low hardness, 6 to 6.5 on the Mohs scale, the aforementioned cleavage planes, and brittleness. So they're easy to scratch, easy to chip, and easy to split. Straight into F tier. So those are the glass cannons. Beautiful stones that look amazing right until you actually try to wear them on your finger. Let's move into the middle of the colored gemstone world, the stones that some people call semi-precious. Some of these are great, some are overpriced, and some are secretly fantastic value. Morganite is a variety of beryl, the same mineral family emerald is made from, just without so many cracks. That gives it a lot better durability. Beryl is about 7.5 to 8 in the Mohs scale, has no real cleavage, and generally survives everyday wear decently well. However, Morganite has a weird little flaw. It loves getting oiled up. Not because the crystal is uniquely absorbent or chemically strange, but because Morganite is usually pale, often cut with big open facets, and tends to show a thin film of skin oil, sunscreen, soap residue, and general human grease very clearly. On top of that, some stones have tiny surface-reaching fractures which can make their dullness even more obvious. So a fresh, clean Morganite can look bright and peachy, but after a few weeks of normal wear, it can look like someone rubbed it with butter. The good news is this is reversible. You just drop it in warm water with a little bit of dish soap, give it a quick brush, and it goes back to normal. The bad news is you'll be doing that very often. That's why it lands in D tier. Aquamarine is mechanically pretty good on paper at a 7.5 to 8 on the Mohs scale and has no real cleavage, but in my experience, it chips more often than you'd expect, especially around the edges. Compared to something like Garnet or Spinel, it just doesn't take abuse nearly as well. But the main problem is the color. Most Aquamarine on the market is extremely pale. If you look at high-end stones like Santa Maria Aquamarine, the color is incredible. It's like this deep ocean blue, but those stones are rare and very expensive. The vast majority of Aquamarine sold in jewelry is so light, it's basically tinted water. I've had clients in the past say this exact thing. It's not as blue as I thought, because when you hear Aquamarine, you think of this color. It's to the point where I actually now warn people if they want to buy one, which creates a bit of a weird value problem. You're paying for a blue gemstone that doesn't actually look very blue. The really good ones are amazing, but very expensive, and the other 95% look like someone whispered the word blue at a piece of quartz. That's why it's going to be landing in C tier. Tourmaline is one of the most interesting gemstones chemically. It's not a single mineral, it's actually a whole group of related minerals. That's why it comes in so many different colors. Green, blue, pink, and sometimes multiple colors in the same crystal. You can actually see stones that fade from green to pink along the length of the crystal. People call that watermelon tourmaline, which is honestly one of the coolest looking natural gemstones. Mechanically, it's decent. It sits at about 7 to 7.5 on the Mohs scale, has no meaningful cleavage, and generally survives normal wear decently well. But it does have one weakness. The crystals tend to grow in long brittle prisms, which means they can chip along the length if they take a hard hit. So it's a solid gemstone, but not exactly indestructible. Durable enough for jewelry, beautiful colors, usually reasonably priced. That puts Tourmaline in B tier. Topaz is a weird one. On paper, it looks fantastic. Topaz sits at about 8 on the Mohs scale, which makes it harder than quartz and harder than garnets. So mechanically, it should be a great stone. But there's a catch. There's always a catch. Topaz has perfect basal cleavage. Remember what we said earlier? This means the crystal has a built-in structural plane where it really likes to split. If it takes a sharp hit in the wrong direction, it doesn't chip like sapphire or spinel. It can literally shear cleanly in half. Topaz is notorious for doing this. So it's very resistant to scratching, but not particularly forgiving when it comes to impacts. Now aesthetically, Topaz actually has something going for it. The blue varieties you see everywhere, Swiss blue and London blue, are usually created by irradiating colorless topaz. Topaz usually comes out of the ground without any color, and this treatment looks absolutely sick. Swiss blue in particular is basically the color Aquamarine wishes that it was. It's this electric, saturated blue that Aquamarine almost never reaches. And because Topaz is so abundant, those colors end up being actually quite affordable. So visually it can be beautiful, the stones are usually large and clean, and the price is very reasonable, but that perfect cleavage means there's always a structural weak point running through the crystal structure, which is why Topaz is going to end up in C tier. It's not terrible, but it's definitely not something I would trust the same way I would trust stones later in this video. Tanzanite is one of the most geographically rare stones on Earth. It's only found in a small mining belt in the Merilani Hills of Tanzania near Mount Kilimanjaro. Nowhere else on the planet produces it that we know of. And this is why so many gemstone dealers will sometimes call it a single generation gemstone. If those mines run out, new supply could disappear entirely. But Tanzanite is only about a 6 to 7 on the Mohs scale, so everyday dust can slowly scratch and dull the polish. It also has perfect cleavage, meaning a sharp hit in the wrong direction can crack the stone, and the famous violet blue color is pretty much just a post-mining heat treatment. So Tanzanite is rare, but it's also soft, fragile, and quite high maintenance. Personally, I would just get a violet sapphire. I think Tanzanite is pretty overhyped. It's going into E tier. Amethyst, citrine, ametrine, smoky quartz, rose quartz, rutilated quartz, carnelian, onyx, and so on. These are all just different colors of the same mineral family, quartz. Quartz sits at about 7 on the Mohs hardness scale, which means everyday dust, which also contains quartz just floating around in the air, can slowly abrade the polish over time. They're very affordable, they're quite common, and they look good, but they're not exactly heirloom grade. C tier feels right here. Peridot goes into D tier. Beautiful color, but slightly softer and more brittle than quartz, except palisade peridot, which gets S tier immediately because it literally came out of the core of a shattered planet. After this video, go watch my short on it if you haven't already. The origin story is absolutely ridiculous. So far, we've mostly been talking about colored gemstones, but obviously the jewelry industry doesn't stop there. At some point, people realize something. What if instead of chasing color, we just chased absolute maximum sparkle? Synthetic rutile was one of the early attempts at this from the 50s. Throws absolutely silly amounts of fire, way more than moissanite, 6 times as much as diamond, which is why some people absolutely lose their marbles over it. But it's only about 6 on the Mohs scale, it scratches easily, and many stones slowly yellow or haze over time. Incredible sparkle, but terrible longevity. It's going in E tier. Cubic zirconia is sparkly and surprisingly durable at about 8 to 8.5 Mohs, but the facet edges slowly round off with wear, so it loses its crispness over time, but I'm still putting it in B tier because it's so cheap it's basically free. This is what I used when I was learning to set stones. Fun fact, when cubic zirconia hit the market in the 80s and 90s, it briefly terrified the diamond industry because suddenly anyone could buy a huge, flawless diamond for fairly cheap. It was basically lab diamonds before lab diamonds existed. Moissanite has one of the strangest origin stories out of any gemstone. In 1893, a chemist named Henry Moissan was examining fragments from a meteor crater in Arizona when he found tiny crystals. He initially thought they were diamonds, but they turned out to be silicon carbide, a completely different material that almost never forms naturally on Earth. Natural moissanite is so rare that basically all moissanite used in jewellery today is lab grown. And from a materials perspective, it's actually kind of ridiculous. Moissanite sits at about 9.25 on the Mohs scale, which makes it the hardest gemstone available except for diamond. It's extremely tough, very stable, and it keeps its polish for decades. Moissanite can also be grown in different colors, blues, greens, and even champagne tones, but the real party trick is the optics. Moissanite has insane dispersion, which means it doesn't look as sharp as diamond, but it splits light into rainbow colors a lot more. That's why moissanite looks so rainbow and has these huge flashes of colored fire. Some people love that look, some people think it's a little bit too much, but either way, you're ending up with a stone that is almost as hard as diamond, extremely durable, very pretty, and dramatically cheaper, which is why moissanite is the first stone on this list to land comfortably in S tier. If you like the rainbow fire, this is 100% your stone. Natural diamonds. Mechanically, diamonds are incredible. They're the hardest natural material on Earth, and they keep a crisp polish basically forever. But the problem is price. Natural diamonds are extremely expensive in my opinion for what you're actually getting, largely because a century of marketing turned them into the default and only engagement stone. They're rare, sure, but not $10,000 per carat rare, and unless you really know what you're doing with cut, clarity, color, and the certification, it's very easy to accidentally overpay. You also need to be careful where they're coming from. Today's supply chain is vastly cleaner than the one from 20 to 30 years ago, but there's still always a tiny risk of getting sketchy stones, especially if you're buying from a dodgy dealer. Honestly, when a client tells me they want a natural diamond, my first reaction is usually, are you sure? Don't get me wrong, obviously it's great for business, but when someone is about to spend $20,000 or more on a 2-carat colorless stone, part of me wants to say, you know, you could get like the best sapphire of all time for that money, right? Because of the price, I think they have to be in C tier. Lab diamonds. These aren't simulants like cubic zirconia or moissanite. Lab diamonds are actual diamonds. The same crystal structure, same Mohs 10 hardness, same optical properties. The only difference is that they're grown in a machine instead of mined out of the earth. Mechanically, they're completely identical. They keep a razor sharp polish forever. They also eliminate a lot of the traditional issues around diamond sourcing. Modern natural supply chains, like I said, are much cleaner than the ones from 20 to 30 years ago. But with lab diamonds, the origin is very simple. It came from a factory. The big difference though is price. Without geological scarcity and extraction and sourcing costs, the price drops dramatically. A stone that might cost tens of thousands as a natural diamond can often be bought for a fraction of that in lab form, sometimes even less than 10% of the natural cost. Honestly, the main problem with lab diamonds is that they're too cheap. People will suddenly realize they can afford 5-6 carat stones and then mount them on tiny little bands that have absolutely no business holding something that big. But purely based on performance, durability, optics, and value for money, lab diamonds are also an easy S tier. Diamonds are the king of hardness. They're the hardest natural material on Earth. But like I keep saying, hardness isn't everything. Diamonds actually have perfect cleavage, which means under the right impact, they can actually split cleanly across those crystal planes. It happens more often than you would think. And aesthetically, they're kind of one note, unless you want a blue or pink diamond, but at that point, you better be very rich. So what if you want gemstones that are incredibly durable, but also have real color without the insane markup? Let's talk about the stones that jewelers quietly love the most. Spinel might be the most underrated gemstone on Earth. Mechanically, it's fantastic. It sits at about 8 on the Mohs scale, has no cleavage, and is very tough, which means it handles everyday wear extremely well. But the really funny thing about Spinel is that historically, people thought it was ruby. Some of the most famous rubies in crown jewels turned out to be red spinels once scientists actually started analyzing them. And Spinel actually shows up in different colors too. Hot pink, cobalt blue, lavender, orange, even black. So you end up with a stone that's durable, very attractive, and still relatively affordable compared to ruby or sapphire, which makes Spinel another easy S tier. Garnet actually isn't a single gemstone, it's a whole family of minerals, which is why they show up in so many different colors. Mechanically, they're very solid stones. Most garnets sit about 7 to 7.5 on the Mohs scale, but they have no cleavage and they're reasonably tough, which makes them pretty good for everyday jewelry. That might sound similar to quartz on paper, but garnets tend to handle impact and edge wear better in real jewelry, so they generally hold up a bit nicer over time. Some varieties are genuinely stunning too. Tvorite is a vivid emerald green garnet that's cleaner and tougher than emerald itself. Rutile has this beautiful raspberry color. Even the classic deep red or molding can look fantastic in the right cut. They're durable, colorful, and usually far more affordable than stones like ruby or sapphire, which is why garnets land comfortably in A tier. Except Dementoid, which is gorgeous, but it's a bit softer, so that one drops to B tier. Chrysoberyl is one of those gemstones that almost nobody talks about for some reason, but from a materials standpoint, it's incredible. It sits at about 8.5 on the Mohs scale, which makes it harder than all but one colored stone, and it's also very tough. Mechanically, it's one of the most durable colored gemstones you can buy. And one of its varieties is Alexandrite, which famously changes color from green in daylight to red under incandescent light. The only real problem with Chrysoberyl is the price for some of them. Fine Alexandrite in particular is absurdly expensive and rare. Most people will never see a real one in their entire lives. When a client asks me to set one, I'm usually quietly shitting myself. Purely on durability and optical performance, Chrysoberyl easily would earn an S tier, but because of the insane price tag, it has to go in A tier. Corundum. Finally, the king of colored gemstones, Corundum is almost the perfect jewelry material. It sits at 9 on the Mohs hardness scale, making it one of the hardest natural materials on earth, except for diamond. It's extremely tough, extremely stable, and it keeps a crisp polish forever. The real magic is the color. Ruby is actually just red Corundum. It gets a special name. Everything else, blue, pink, yellow, purple, green, even color changing stones, they're all varieties of sapphire, which is Corundum. So you get a gemstone that's almost as hard as diamond, more durable than diamond when you consider the toughness, and available in basically every color you could possibly want. And unlike a lot of the gemstones we talked about earlier, Corundum doesn't come with some hidden structural flaw waiting to ruin your whole week. No cleavage, no internal fractures by default, there's not some weird chemical catch that makes it fall apart if you wash your hands a certain way. It just works, which is why jewelers love it. If Corundum didn't exist, choosing gemstones for jewelry would honestly be a lot harder, which is why it doesn't just get S tier, it gets God tier, the best colored stone. I love Corundum so much. Gemstones are sold like mythology, but underneath the marketing, the rarity, and the prestige, they're still just materials. They obey the laws of physics, and physics does not care what something costs. Doesn't matter how famous the stone is, doesn't care how many centuries of prestige it has behind it, and it definitely doesn't care what the sales guy told you. A gemstone can be rare and still fragile, it can be expensive and still be a terrible choice for a ring, but a few of them are genuinely brilliant materials. If you want to go deeper into the physics, history, and other secrets of the jewelry industry, you can access my book for free in the description. And if you're curious what this metallurgy looks like when it's actually applied, the pieces I make are on my website, as well as applications for custom requests. Otherwise, now you know what you're putting on your hand. I'll see you in the next one.